So this is a pretty challenging calculus 1 question. We are going to evaluate the limit as n going to infinity of the summation I starts at 1 up to n, and then we have I times the square root of I squared minus I squared over n cubed. Wow, how do we do this? Well, first thing first. If you see a limit and then summation, especially when you have the I going from 1 to n, yeah, this is going to be a Riemann sum question. And we are going to just convert this into an integral and then evaluate the integral. But remember, in order for us to do that, we should see the delta x, which is the b minus a over n part. But we don't see that here. Well, the key right here is that notice to get the delta x, we must have a number over n to the first power. But this is n to the third power. We don't want that. We just want n to the first power. And also, the top should just be a number, not a random index I. So let's rewrite this a little bit. So still have the limit, n going to infinity, summation, I goes from 1 to n. I want to have a number. I don't see any actual numbers like 2 or 5 written, but you know there's 1, so we can use 1. So I'm actually going to write this as 1 times that. That's okay, so it's 1 times. And then instead of n to the third power, I'm going to have, just put down n to the first power like that. And then I will have the I right here over n, I need 2 more, right? So like this. And then of course we have the square root, n squared minus I squared. Okay, that looks pretty good. So it looks like our delta x is 1 over n. Okay, so that means b minus a is equal to 1. So if we start at 0, we have to go to 1. If we start at 17, we go to 18, etc. Okay, next we have to remember that xi is equal to a plus whatever the I is times delta x. So in this case, we should focus on a plus I times 1 over n. So we should focus on the I over n part. I have I over n squared, so I'm going to break it down again. So let me rewrite this one more time. But for this, I will purposely write it as I over n. So that will be the input x later on. But we have one more n right here. That's kind of strange. I'm going to write it down. 1 over n here again. And then we still have that thing right there. So this is making me nervous. That's why I told you this is a challenging question. Okay, now what do we do next? In fact, I don't really want to see 2 of the 1 over n. So what can we do? We can actually put this inside. In fact, you can see that we should really do that because here we only have I squared. We want to see I over n. Have a look. When we put this inside, on the outside we have n to the first power. On the inside, we will have n squared. So we will have the square root. Here is n squared minus I squared. Just go ahead and divide it by n squared. All right? And then we can split the fraction, and then you can see that this right here, we're almost there. N squared over n squared is just 1. We have the minus. Notice that they both have the second power, so we can put a parentheses and write I over n like this, and then to the second power. Whew. So now, ladies and gentlemen, this right here actually gives us much faster this way. This right here gives us the following. Here is a small part you have to pay attention to. The 1 is not the a, because notice that you have the I over n here and then square. So there's no number right next to the I over n here. A is 0. So we are just going to have the integral going from 0, because it was 1 over n. If you start at 0, right here will be 1. And now this is the input x, likewise that. So we have x square root of 1 minus x squared. And then don't forget the dx. Okay, now we can just go ahead and evaluate the integral. To do so, we will have to do u substitution. Because the inner function's derivative has negative 2x. We can cancel out the x right here. So I'm going to let u equal to the inner function. That way, du is equal to negative 2x dx. Let me divide the negative 2x to both sides. So I get du over negative 2x for the dx. And now we can take this integral to the u world. But be careful though. Here, this is when x is equal to 0. We will have to put that here, and you see that u will be 1 minus 0 squared, which is 1. So u starts at 1. And then right here, when x is equal to 1, u will be 1 minus 1 squared, which is equal to 0. So u will be 0 here. And then continue. Here we have the x. Here we have the square root. This part is our u. Dx is du over negative 2x. As you can see, the x and x cancel. So there's no x in the u world. That means we are good. And we can totally integrate square root of u in the u world too. But let me put down the 1 over negative 2 to the outside here. And then here we have the integral going from 1 to 0. And then square root of u du. In fact, if you look at this, this is kind of strange because this number is bigger than that. That's not usually the case, right? It's out of order. It's okay, because thanks to this negative, and then by using the property of integral, you can actually negate the result and then switch the integral. So this becomes positive 1/2, and the integral going from 0 to 1. Okay? Again, just the integral property. And then right here, u in the square root, it's the same as u to the 1/2 power. Write it down like this, so we can do the reverse power rule. Let's go ahead and add 1 to the power, which is 3/2, multiplied by the reciprocal of it, which is 2 over 3. So we have 2 over, well, the 2's cancel, so we just have 1 over 3. And then u to the 3 over 2 power. And because at the end, the answer is just going to be a number, so you can finish everything in the u world, and we just care about plugging 0 and 1 into the u. 1 goes in first, so we have 1/3, 1 to the 3/2 power, and then minus plugging 0, 1/3, and then 0, and then 3/2. Of course, that's just 0. 1 to this power is just 1. So all in all, the answer is equal to 1 over 3. And then we're done.